Okay, so hello, good morning to all of you. Welcome to today's webinar session titled Design Secrets Revealed. I'm JJ Chen, I'll be your presenter for today. Okay, so first and foremost, Merry Christmas. I hope you guys have a great holiday ahead. But before that, let's just start with our 1-hour session webinar for today. So firstly, let's take a look at the summary for today's webinar. We'll be taking a look at some spline basics. Okay, so spline may not be a very common tool when we are doing our designs, but it is definitely a very powerful tool. But let's just take a quick look at the basics, and then we'll see some optimal material flow examples using splines and how it can actually help to optimize your material flow design. Then we will also see some sketch blocks in mechanical design. So we will also be taking a look at examples on assembly movements. So before we even have individual parts and putting it into assemblies, we can actually utilize sketch blocks first to actually evaluate the movement and the motion of our desired requirements using sketch blocks only. So let's take a look at some spline basics. So creating splines, okay, it's of course it's one of the freehand geometries under the sketch tab in your command manager in SolidWorks. So 3 points make a spline, and the fewer points that you have, the better. Okay, because the more points that you have to define your spline, the more difficult it is to get the desired shape. Then we'll take a look at what are spline handles. Okay, we'll see the spline property manager. Okay, we can also add some relations like tangency, horizontal, or perpendicular constraints to our splines. Dimensioning, of course. Mirroring and curvature constraints. How to fix a spline. Okay, and fit spline. Proportional. And last but not least, style spline. Okay, so style spline it is actually a new feature in SolidWorks 2014. So the creation of style spline is slightly different from a normal spline, and we'll see how that actually benefits us. So here, all in all, for the spline, we'll be taking a look at their curvature combs. So we can actually see the results as we design our splines. So let's go on to SolidWorks. Okay, and just take a look at some examples on splines. So as I mentioned earlier, the spline will actually be located here under the sketch tab. So here I'm just going to start a new sketch and click on spline. So firstly, I'm just going to put 3 points, something like this, 1, 2, and 3. Then click escape there. And that essentially is already a spline. And when I select this spline that I've just created, you'll see that I actually have some handles over here, some diamond shapes as well as some arrows, okay, on each of the points that I have created. So if your point is on the end, you'll only have one single spline handle, and if it's in the middle, you'll see that you will have 2 spline handles, one for each side. So how do we actually manipulate these spline handles? So we have the diamond shape here, which is essentially used to control the degree of your spline, okay, of this point right here. Okay, and for the arrow, okay, it determines the length of your spline. So you can move that about to get your desired shape. Okay, so you can just play around with it, with your spline handles and all. So you can move one of it, and if I hold down the alternate key, if I want it to be symmetrical, I can pull one end and the other will follow as well. So that is the alternate key. So when we select our spline, of course, the spline property manager will also appear right here. Okay, so normally it will just show you existing relations. You can add a relation and all. And you can also reset all handles, okay, to how it was originally created. Okay, or you can just reset this handle itself, a specific handle. Okay, so next we can actually add in constraints as well, or relations, okay, as shown right here. So here, how do I add the constraints is, if I select this spline handle right here, I can actually ask it to be vertical. So when I do so, this spline handle will be vertically, and I won't be able to fix the to change the angle anymore, as it turns black, which means that it is now defined. Okay, but I can reset all handle, okay, or I can delete this relation right here and reset the handle once again. So for dimension wise, okay, of course, okay, never mind, let me just add back this vertical relation. Okay, and for dimensions, we can actually create dimensions on the handle itself. If I select this handle, you'll see that I can actually drag out a dimension and just place it right here, and then just give it a dimension of 150 or whatnot. Okay, I can give this a horizontal if I want to. Okay, so next, here I'm just going to delete all these existing ones. Okay, let me just reset this spline to how it was. So the next thing I'm going to talk about here is the fix. Okay, so why making it fixed, make this spline fixed is important. So what I'm going to do here is I'm just going to create a different spline. Okay, I'm going to create a second spline right here. Okay, and I'm just going to put this right here. So what I'm going to do next is I can actually add a tangent relation between these two splines. But you can see when I add this tangent right here, okay, it doesn't ensure that, oh, how do I actually ensure that the tangency that I move is the bottom spline that I've just created instead of the upper spline? Because as you can see now, when I add in my tangency relation, my upper spline actually changes its position. So what if I do not want that to happen? Okay, so right here, I can actually just make this one fixed temporarily. And then after that, just add in my tangent relation. And once I'm done with that, I can now delete my fixed relation. Okay, so all is good there. So all is good there. And that's how you create a fix. That's how you use the fixed relation. Okay. So next, what if I want, after I've created a few splines, I want them now to be a single spline. Okay. So you might think, oh, why not I use a composite curve? Okay. But let's rethink back. Composite curve is actually created based on two different sketches. Okay, you can make two different sketches into one single sketch. Okay, to create by using composite curve. But in this case, it is not exactly so because it is still a single sketch. It's still sketch 2. It's just that we have two different splines. Okay, so what we can do is we can select both of this and we hit fit spline. Okay. So here, I'm just going to use the fit spline tool. So once I've selected both of these, I can now click OK, and I can actually choose it to be constrained, unconstrained, or fixed. Okay, or I want it to be a closed spline. So in this case, I'm just going to click OK, and it now should be a single spline. Okay. So, okay, let me just delete this one first. I'll show you another example of proportional. So let's create a spline like this. Okay, so by hitting the proportional option right here in the spline property manager, you can see I can actually move this entire spline as a single sketch. Okay. And if I fix one point right here, you can actually change the size as well. Okay, and it will stay proportionate. Okay, the shape will be the same. You can adjust the size like this or just move it around. Okay, using the proportional option. But if not, of course, I'll be moving individual splines instead. Okay, so lastly, we'll be taking a look at style spline. Okay, so here I can select style spline, and the creation of the style spline is slightly different. Okay, so let me just show you. Normally, when we create splines, if it's just a simple spline, I just create 3 points or 4 points, and I manipulate the spline handles. So using the style spline, okay, I actually draw lines instead. Okay, so using this, if I'm creating construction lines and the spline will appear referencing to the lines, I can just adjust these points instead of the spline handles. So by using style spline, it is actually relatively much easier for you to get your desired shape. Okay, let's say you are actually tracing a vase, okay, from your conceptual designs and everything. Using the style spline, it is much easier to capture the desired shape. Okay, so personally, I would actually use style spline as well, but of course, the spline as well as the style spline each have its capabilities and appropriateness in your designs. So lastly, we are going to take a look at the curvature combs as I mentioned earlier. So that is where we can actually see the results as we proceed with our design. So here, I'm just going to create a spline, okay, just between these 2 points. Okay, just between these 2 points. So here I can actually manipulate the angle and everything, okay, and whatnot. So yeah, I missed out something earlier, which is actually mirroring. Okay, and for me to actually get if I want it to be a symmetrical spline, okay, of course it is easier for me to first create one-sided spline like this. Okay, and here if I right click on this spline, I can actually show the curvature combs. Okay, so to ensure that the so for curvature combs, it actually shows how the smoothness of your spline. And as I change the angle or the length of our splines and all, okay, you can see how it actually affects this curvature combs. So of course we wouldn't want it to have something like this. Okay, we do not want the smoothness to have abrupt changes. Okay, so it actually all depends on your design. Okay, because it also shows the acceleration and the deceleration of your spline. Okay, so of course using this I can, if I want to, let me just give it a horizontal. Can just move this so that it's not too crazy. Okay, so anyways, let me just create a mirror entity. Okay, let me just create a center line right here really quickly. Okay, so obviously you want to move that up as well and change it. Okay, so you do not have such abrupt changes and all. Okay, so of course mirroring is essentially the same as any other sketch entities as well. Okay, so here the curvature combs actually shows the take-home point here is actually the most important one would be the curvature combs because it actually shows the smoothness, okay, as well as the acceleration or the deceleration. Okay, so taking a look back to our slides here. Okay, oops, let's go to the next. Let's go to the next one. Yep, so we've seen this, which is practically the style spline as well as the curvature combs, okay, on this part right here. Okay, so next we'll be taking a look at an example on the optimal material flow. Okay, so as I mentioned earlier, the curvature combs of these splines actually plays an important role when you are doing your design. Okay, so take a look at these two hourglass right here. Okay, so I'm giving credits to Jeremy Singley for the materials. Okay, so taking a look at these two hourglass that we have. Okay, on the left we have an ordinary hourglass, and on the right we have a somewhat magical hourglass shape. Okay, so overall the shape is actually the same. So what exactly makes the right one ordinary and the left one magical? Okay, so previously we have actually already traced the shape, okay, for your of this using the spline tool. Okay, but let's take a look at the ordinary hourglass first. So I have a video right here that I'm just going to play, and let's take a look at this specific speck of sand right here. So throughout the entire journey, okay, of the sand flowing down the orifice and everything, you'll notice that this speck of sand doesn't really move much. Okay, if not at all as well. But why is this so? Okay, so depending on how the shape of your hourglass is, this spec is actually being pushed and being pressed down by the others in the middle. Okay, the middle ones are actually pressuring it to the side. So it won't be able to go through because until all the one in the middle has actually been filtered down towards the bottom half of the hourglass. Okay, so you can see throughout the entire video, this spec actually hasn't moved a single bit. But if we take a look at the other hourglass, which is deemed to be magical, okay, let's take a look at this speck of sand right here. And when I click play, immediately you'll see that it's actually moving. Okay, and it's going a little bit faster and faster. So in no time, it is actually past its point from the arrow. Okay, you can see how fast it's actually going right now. Okay, and giving a few more seconds to it, this speck of dust will just go right through the orifice right there. Okay, so obviously this shape is not really constrained or bothered by the sands in the middle, okay, of the hourglass right here. Okay, unlike the one earlier on for the ordinary one. Okay, so as the shape is slightly different, okay, although the overall shape is the same, okay, you can see that the middle part of the hourglass is much more bigger. Okay, and when it reaches this point at the orifice, it actually slows down. Okay, so why is that so? Yeah, so if we take a look at the original spline, okay, that we have traced over the ordinary hourglass, okay, so this is what we have traced. And if we take a look at the curvature comb, you'll see that it will actually show the acceleration and the deceleration of the curve. Okay, so at the starting right here, it is actually slow, and then it goes up. So same thing right here at the bottom as well, that it actually decelerates when the time comes at the orifice. Okay, so here you can see everything will be accumulated up here, and that is what caused the flow to be stunted or slowed down. Okay, so what about the magic hourglass trace spline? Okay, so if we trace the hourglass, the magical one. Okay, this is the spline. The shape is of course almost the same. It is the ordinary magic glass. We just put it on the same figure. Okay, you can see there's actually just a very slight change. Okay, the shape is maintained. It's just a slight change in the acceleration in the shape. You can see that the acceleration it's much higher here. So as it goes down, it goes much quicker. Okay, so instead of straight lines when you are doing your let's say a flow or a filter like this, okay, when you're doing your design, instead of straight lines, okay, let's take a look at an example right here. If it's a straight line, okay, let's delete this first and create a spline instead. Okay, I'm just gonna connect it from these 2 points. Okay, so utilizing the shape, okay, here I'm just gonna give it a vertical, this one as well. Okay, and let's just show the curvature comb. Okay, so this is exactly the ordinary one because it starts to slow down right here. Okay, so what if I change it like this? Okay, I make both ends shorter. Okay, And my curvature comb will now have a very obvious acceleration at the end here. Okay, so that is exactly what I want. So I can now just give it a dimension, maybe 60. Okay, for the top as well as the bottom. Okay. So with that, this is now a much better design. Okay, and it still looks straight, but not quite. Okay, so that's why instead of straight lines, why not try splines? Okay, to actually get the acceleration at the end of your funnel. Okay, so next we'll actually be talking about sketch blocks in mechanical designs. Okay, so for sketch blocks, what it does, it actually groups multiple pieces of sketch geometries and dimensions together, and then it will start moving as one in a sketch. So sketch blocks in layout-based assembly designs can create in-context parts. So if you're using sketch blocks in your layout-based assembly design, you can straight away create in-context parts in the assembly itself, okay, utilizing these sketch blocks. So you can also use these blocks to represent the motion of an assembly in a 2D environment first. Okay, not necessarily you need to have all the individual parts and then you put it into an assembly and then you test out the motion. Well, that is very common these days, okay, of course. Okay, that is what we normally do as well. But what if we want it to be even faster? Okay, if we want it to be even faster, we can actually use these blocks. Okay, these sketch blocks. So here, there are a few steps out of this. First, we create the blocks, and then we add it to a assembly. Okay, then we just add relations and test the initial assembly mechanisms. Okay, and lastly, if after that, after creating all the sketch blocks and everything, you can create a part from the block. Okay, so here I'm just going to go to SolidWorks. Okay, I can close this first. Okay, so here what I'm going to do is I'm going to create a new assembly. Okay, and I'm going to just choose assembly MM. Okay, so instead of inserting parts, what I'm going to do is I'm going to click create layout. Okay, so this will be a 3D sketch. Okay, and now it is actually created on the front plane. Okay, and it will also have some grid showing as well. So what I'm going to do is I'm just going to orient to the front plane and just create a sketch. Okay, so here I'm just going to draw it something like this. Okay, so this will actually be my base. 50 right here, 42, and 17. Okay, so after creating a sketch, this is actually just a simple sketch first. Okay, what I'm gonna do next is I'm gonna select under the layout. Okay, I'm gonna click make block. So for the block entities, of course, I'm gonna select all three of these. Okay, the three lines that I've just created. And here I'm just gonna define my insertion point as well. Okay, so this insertion point is where the point of the cursor will be attached to when we are inserting instances of this specific block. Okay, because Once I've saved this as a block, I can actually export it. Okay, I can put it into other assemblies as well. Okay, and for a reference guide, I'll put the insertion point right here. Okay, and just click OK. So I can now move this about. What I'm going to do is I'm going to add a coincident relation between this point and the origin. Okay, so after I place that, of course I can still rotate this around. Okay, and given that this sketch is now a block, I can actually move the entire sketch like a single entity. Okay, something similar to the proportional relation or the proportional option that we've added to the spline earlier on. Okay, so here I'm just gonna give this a horizontal relation as well, just to make that fixed in split in place. Okay, so I'm gonna rename this block and I'm gonna call it base. Okay, so next, what I'm gonna do next is I'm gonna create a rectangle right here. Okay, for my secondary so-called part. Okay, but in this case, just a sketch first, because I want to use this to identify the mechanisms. Okay, so I'm just gonna quickly draw a rectangle right here. Okay, I'm gonna make this construction. Okay, I'm gonna add in a few points as well. Okay, easier for me to identify my insertion points as well as some connection points with other parts. So here I can put 10. Overall I can put 15. Length is 100. Distance between the 2 points is 25. And this is 9. Oops, upside down. Okay, from the bottom one, that is 9. Okay, so with this, I'm gonna make this into a block as well. Okay, of course, block entity is everything. And for the insertion point, I'm gonna put it right here. Okay, at the first point that I've just created. So click OK, and I should have a block like this. So what I'm going to do is I'm going to select this point, okay, and I'm going to connect this endpoint to this endpoint of the base. Okay, I'm going to add a coincident relation right here, as you can see. Now I'll be able to freely move this part right here. Okay, not necessarily, it's not really a part. Let me just rename this. Okay, block 2, I'm just going to rename it as arm. Okay, so I can freely rotate this arm block. Okay, so next I'm going to create a new part instead. Okay, so like what I've said earlier, okay, we can actually have the insertion point, okay, and I can import and export sketch blocks. So what I'm going to do here is I'm going to create a sketch on the front plane. I'm just creating a straight slot right here. Okay, just something like this. Next I'm going to add a point on my center line of this slot. and just give it a dimension, some dimensions to define it. So this is 10, center line is 125. Okay, and the point to the origin, or to one end point of the construction line, I'm going to put 67. Okay, so here I'm gonna save it as a block. Okay, and how do I do that? Is I select all of these. Okay, and here you see I have a make block icon right here. Okay, the make block icon. Okay, or of course if you do not know where to find this feature, we can also search for it. Okay, so you can click make block, select the entities that we want, which is slot and the point. Okay, for the insertion a point, I'm gonna put it right here. Okay, add the origin and click OK. Okay, so you can see now we have a block. Okay, so I'm going to save it in the local. Here I'm just gonna right click and I'm gonna click save block. Okay, here maybe I'm just gonna save it in my desktop and I'm gonna name it handle. Okay, so with that I can actually discard this and even close this part without saving the part. Okay, next, of course I've created the handle. Now I want to put it back into my assembly. So I'm gonna click insert block. Okay, and I'm gonna browse for the block that I've just created, which in this case is of course the handle. And the file format for the block is SLD-BLK. Okay, so I'm gonna click open. Okay, so you can see my cursor will be at the point of my insertion point that I've just added earlier on. Okay, so what I'm gonna do is I'm gonna put this one. I'm gonna add a coincident relation between the endpoint of my slot to the endpoint of the base. Okay, so next I actually have some other blocks as well. Okay, so what I'm gonna do is I'm just gonna insert block. I'm just gonna browse to what I have. Okay, in this case it's right here. Okay, and I'm just gonna add in the link block. So here I'm just gonna add it anywhere first. Okay, and I'm just gonna browse for a second one, which is in the same location. Just quickly navigate there. Okay, and I'm gonna add a hold down block as well. Okay, so here I can click OK or I can click close to finish adding some blocks. Okay, and next I'm gonna add some relations. For example, this link, I'm gonna add a coincident right here. Okay, and a coincident between the point. Okay, so you can see I actually will have something like this. Okay, the link will now be linking my handle, okay, the handle and my arm together. Then next I can also, for this hold down, I can add a coincident right here. okay, and add a collinear right here as well. Okay, so here I can now move my mechanism around, okay, and see how it actually moves. Okay, how is the mechanism of my potential design? Okay, so this can be a preliminary design concept testing. Okay, and what if I've tested it and I realize, yes, I do need to change something. Okay, before I even create the part, I'm going to do some changes. So here, let's say if I want to do some changes to the link block, I can right click the link block in the graphics area, and I'll just click edit block. Okay, so here I can actually change up the dimensions. So instead of 25, maybe I'll give this a 30. Okay, and when I exit my block, okay, and if I drag it again, you can see everything is now updated automatically. Okay, so that is nothing less to expect from SolidWorks, of course, given that the automatic update is quite prominent in SolidWorks. Okay, so right now, after evaluating all this mechanism and all, I can exit the layout. Okay, so and here, lastly, let's just try to make a part out of all these sketch blocks that we have. Okay, so for example, I can right click on the base block, okay, and I'll have the option to make part from the block. Okay, so selecting that, okay, you can see I have the selected blocks, okay, and I can block to part constraints. Either I want to project it or want to create it on block. So here I'm going to use the on block option, okay, and I'm going to click OK. Oops. Okay, so here I'm just going to right click on this new part, okay, and I'm going to open this part right here. So this base block is actually now a SLD PRT. Okay, so here we can actually create a new sketch on the front plane. Okay, and I can add in some other geometries. Okay, because of course I can't just have these three lines right here. So what I'm going to do is I'm just going to create some new geometries as well. Okay, so something like this. I'm just going to get the overall shape. Okay, just the overall shape right here. And then I'll just add in some constraints. Okay. Okay, and then I add in some dimensions right here. So in this case, I can put in 15. Okay, I can give this 5, and I can make this 2 equal. With that, I now have a completed geometry, sketch geometry. Okay, it's fully defined. What I'm going to do next is I can now extrude this sketch. I'm just going to give it a mid plane of 20 mm. Okay, so here I can add some fillets, of course. Okay, under features I can add some fillets. So this is now the normal way of how to create. This is just some normal way how to create creating your parts and your blocks from your blocks. Okay, I can add a fillet right here. Okay, and I'm just going to add a shell operation as well. Okay, to shell it out. Okay, parameter wise, I'm going to give it 3. Let's click OK. So then I would have a base part like this. Okay, so I can save this part, close this back, click yes once the model has changed, and now I can now I've now created a part, but bear in mind that this is actually in context. Okay, the arrow assembly 1, this is in context to the assembly that we've just created. So we can move on to create the rest of the parts. So the motion will be the same. Okay, so that is sketch blocks. Okay, oops. And with that, okay, and with that, we have actually gone through all of these. We have created the blocks, either from assembly itself or inserting it from a new part. Okay, add relations, we have tested the initial assembly mechanisms. Okay, and lastly, we've created this part as well. So that will actually conclude our webinar session for today. Okay, quick summary, quick conclusion. We've seen splines, okay, and some basic spline tools. Okay, the take-home point for splines is actually the curvature combs to actually see the acceleration as well as the deceleration of your designs, okay, of the sketch itself. And with that, we can utilize it to actually optimize our flow, material flows, be it air or water or whatnot. Okay, so that will actually be a very quick examination of our model. Okay, so we do not necessarily have to always go to flow simulation and see the flow rate between flow rate through this design part that you have. Okay, using the curvature comb, that is our preliminary examination of the suitability of our design. Okay. Then next we also have the sketch blocks which we've just seen. Okay. So the sketch blocks we've seen how we can actually save parts or save sketches as blocks, inserting it into a layout based assembly to test out the mechanism straight away. And then once we're satisfied with that, we can create the part. Okay, so thank you so much for attending today's webinar session. Once again, I'm Chan Jun Jie, or you can call me JJ. Okay, so you can see my details on the screen right now. My email is there, as well as my phone number. Okay, so if you have any inquiries about SolidWorks, it doesn't necessarily have to only be about blocks. It can be about anything. Okay, it can be about simulation or flow simulation if you're interested. Okay, you can just drop me an email or just give me a ring. Okay, so thank you so much. I shall now end the webinar session for today. Thank you and have a nice day.